And then your question?
I just had a quick question about the first test. Should we even know number 12?
Was that the Sweezy oligopoly?
It's the Iraq thing?
Yeah, no.
The oligopoly. Okay, cool.
Okay. Game theory. You saw me do this in class. I'm going to do it now so that it's on film. Okay, so remember we've got, in game theory, we've got simultaneous and then repeated, or sequential games. So we've got simultaneous. Okay, under simultaneous, we've got one shot.
Was it 12? On the first.
Okay, and then we've got repeated. And under repeated, we have finite versus infinite. Okay? So in a one-shot game, simultaneous game like this, that's the prisoner's dilemma. You find the Nash equilibrium. Bless you. I can also ask you if one firm has a dominant strategy. In a repeated game, finite means I know when the end period is. Okay? In a finite game, is cooperation possible?
No.
No. You would think it would, but it turns out it collapses down to the same as the one-shot game for the underwear bomber rule that I mentioned in class. Okay? But in the finite game, you get the same Nash equilibrium as in the one-shot game. Okay? Now, in real life, if people do this more than, if it's going to be more than like 10 periods, people act like it's infinite. But you're going to ignore that for the test. In the test, we're going to go with the textbook answer, which is, even if I said 1,000 times, okay, your great grandkids are going to be doing it. Doesn't matter. We're going to get the same Nash equilibrium as we would in the one shot. Okay? Infinite. Key on infinite is I don't know when the end is going to be. And so typically I have some question in there on the firms are going to be in the market for the foreseeable future, or this is going to go on for on an ongoing basis with no end in sight. I'll use language like that. And that's going to say, all right, we need to now go infinite. And if it's infinite, repeated game, then what we need to know is that I have to compare the profits of cooperating versus defecting. I can also ask you questions about find the discount rate that makes them indifferent between the two. In a sequential game, those are those decision tree games. On that one, you're gonna use backward induction. So you're gonna start all the way at the right-hand side and move your way back to find the subgame perfect equilibrium, they call it, which is the Nash equilibrium of the entire tree. Okay, so you're gonna solve these by backward induction. Okay, now 34 and 35 I made a little tougher because I didn't actually give you the tables, whereas for 36, 37, and 38 I did. Okay, so I've got firm A is the potential entrant and firm B is an existing firm in the market. firm A must decide whether to enter or stay. So I'm going to make my 2x2 matrix here. I'm going to put firm A on the left and firm B on the top. And I'm going to put enter, don't enter. B gets to play what? Hard or soft. So hard means like you launch a price war, something like that. B says you accommodate. You could also do this one as a decision tree. Okay, so we've got B says hard, soft. I'm actually going to do this one as a decision tree. I think it would be easier to see.